guys, welcome to Bar Z. My name's Stan, and today we're going to go over some of the features and the things I've added to the Hot Shot 360. And the first 8 are already spoken for. Response was real good, so this won't be the last run of them. But let's go over some of the features and some of the things that I've learned. You know, in the past years, I've actually taken classes in value engineering. That means as you're designing something, don't make it cheap, but you can make it economical and affordable by using the right components and learning to recognize a false value. And you know, when you use cheap components, you get cheap results and things like that. So let's go over some of the features of the new Hot Shot 360 and go take a peek at them while they're being made, and some of the things we've added. And you know, some things we add that don't cost anything to do, you know, just maybe a tiny amount of labor or something. But let's go have a peek. Okay, here we've got a batch of ovens. What do you think? This one's getting a serial number. First 2 numbers of the year, and then it's 4 digits in the series. So that's the second oven I built. There's the third oven I built. Fourth. And over here, look at this one. There's number 1. That's the very first oven we built. Not insulated yet. Still waiting on some door hardware. Door handles aren't in yet. Door latches aren't in yet. Controls are started. The controls are just temporarily installed on the sides. All right, you can have a peek. We got the fans put in, and there's a thermostatic control. I'll try to sneak in there. It's adjustable, and that directly controls the fan all the way up to, I think, 130 degrees. We're going to set them for about 120. So that anytime that little controller box is over 120 degrees, it turns the fan on. So it's got, you can see the louvers in that little switch gear. And it's a German-made Flandenberg. We got 120 millimeter fans. There's a cage on both sides of the fan, which that's why I selected those, so that when you put your wiring in here, put the cover on, you don't have to worry about the wires impeding the fan. And then here's the back side. That's what the back looks like. And below is for conduit entry, for bringing the cord in. So the cooling fan, it just blows straight out the back. And what else was I doing? Oh, I was making thermocouples. Let's go look at the thermocouples. I needed a very specific length, so I made these. Now, you can buy these in any length you want. You know, big old long things, and it's better to buy long ones. That you get, it's pretty much the same price for a long thermocouple. This one is a total inserted length of 3 inch. And the way that's going to work, let me show you here with my third hand. The porcelain just bolts to the outside. It's going to be down in the control panel. But then it's got insulators, those 2 little insulated sleeves 2 inches worth, so it'll have a 1-inch insertion length. All right, but that'll be down in the panel. That's where you make your thermocouple wire hookups. And this is a kiln grade thermocouple. It's not one of those cheapies you see on eBay for $10 or whatever. This will hold up to multiple cycles, and those little ones just kind of burn up. I've got a cheapie in the prototype, and I'm trying it. See, there it is there. And it's already showing signs of flaking. Oh yeah, it's starting to flake and separate. So that's a stainless steel tube there. Yeah, it's flaking off. It's getting a little, that thermocouple's not long for this world. And I'm playing with different door latches. These are a stainless steel magnetic, and I had to put 2 top and bottom, and they're pretty good. Still not crazy about it. I am bringing in some double ball latches. Look it up. It's a marine type latch with an adjustable tension, and I'm going to put one right in the center on the prototype and try it. And that's the tough thing about prototypes. This thing's been hodgepodged and tested on, and there's my old door latch there. That's that medieval door latch I had. So it's been tested. You see here, I put a magnet inside of the door. I put one of these just inside. This is just a little insert of insulation. So I had a latch in there. I thought I'd try it in there, and every time it got hot, the magnet got warm enough that it didn't like it, and it kind of faded, so the door would pop open every time the oven got hot, which is pretty worthless. So the ones on the outside, they do work. Not crazy about it, having to add the extra bracketry and stuff, and having to run 2. One just doesn't cut it. So I'm going to try a single ball latch and see if that's going to work on the prototype. My poor oven. See, the prototype ends up being a hodgepodge, ugly, retrofitted, but it's a test bed. It's what we use to test everything on. So anything we experiment with, we experiment on this. All right. Here you can get an idea of the insertion length of that probe. That's how it's not on the top, but you can see that's it going through 2 inches of insulation. So that's how much insertion I'm going to get inside the oven. So it'll be less intrusive than that other one over there. All right. And I'll do a final walk around of all our ovens. I did do a couple of things to them that these are hemmed edges out in front and up on top. Out in front here too. Here you can see the hem. So we don't have any sharp edges facing out. So the oven shells have got a hem on top, back, front, all the way around. And down here on bottom too. There's the hem there. So basically you just go past 90 degrees and roll over your bend. Door hardware is stainless steel continuous. I didn't really like the torsion that these doors had. I wanted some kind of vent, so we left the corners open. I didn't weld those up, but I did put a little TIG weld in each corner, and it took away the torsion of the door. So that's actually the twist this way of the door. So as soon as we tack welded those up, that torsion went away. So it made for a much sturdier door. Okay, here's the oven shelf. These are the heat sinks we're using on the back of the SSRs. These go on the back of the SSR with some thermal paste and get squished on there. And then the fins actually bolt up to an opening down the bottom of the control box. Let's go take a look at that. I got one installed over there. Okay, so there's a cord out of the way. All right, so there's an iDeck SSR. I am using 50 amp SSRs, even though we're only pulling 20. I don't want to overwork them, and they talked about derating them, and literally the 50 amp was just a few dollars more, totally worth the extra insurance. But there is a heat sink bolted to the bottom of that. Maybe I can get you down and see what's going on underneath. Maybe. No, I can't get under there. Those two bolts in that opening go right into that fan. There's a little circular cutout, and those are the two bolts for the SSR. But the air gets swept in through that hole and across that heat sink. Okay, and then over on the left is our porcelain block. That's where our Kanthal wire comes through. Those two openings in the side of the oven, that's where the Kanthal wire comes through, and there'll be porcelain insulators in there, and then a porcelain connector block, and then there's my 3 cooling holes right there. And I kept the holes small enough. You literally, there's my finger. You couldn't stick your finger through there if you tried. You have to put your hand under the oven and try to stick it through that hole. So those slots are, I think they're right at a 1/4 inch. So you can't get your finger in there to get shocked or burned, either one. All right. This is the material I use to weld the thermocouples together. This is a 99% nickel. Available at Matheson Gas, and I'm sure that Airgas and all those other guys have it, but they call it a nickel 99. So just one dot of that after you've struck your arc on the end of the thermocouple, and one blob of that on the end, and your thermocouple's done. Pretty easy. Got the first one on the bench, insulated, and I've got it temporarily wired into my old control, and we're coming up on 2,000 degrees, so it's climbing. And I've got the new probe in there, and the smoke you see is pretty much what you need to expect when you first fire an oven. They just stink. There's contaminants and all kinds of stuff in the kale wool, in the kale wool board, and they just are a big stinky mess. I don't have door latches yet, so what do you guys think of my door latch? Maybe I'll just include a Bessie clamp with every oven. Door latches aren't in yet, door handles aren't in yet, but I wanted to start bench testing some of these boxes and get them insulated, get the element in there, and get them fired. So we are. So I got our Kanthal coming through down there, and there's our probe, and our outside temperatures are going good. I've got 102 on the outside, not bad. This oven here, we were clocking about 160, 170. Let's see. There we are. 102 degrees on the top. So, and then the door is still pretty warm. I didn't make any changes with the door insulation. 137 on the door, which is the numbers we were seeing before on the prototype. So we still got kale wool in the door, but I changed the kale wool board inside the actual oven to medium density type board, and the inner layer is a very high density board. But when you first fire your oven up, it's going to smoke and pop and stink and spit and do all kinds of stuff, and you're going to see these that resin kind of coming out of it. It's burning all the contaminants out of the kale wool is what it's doing. All right, but that's what you can expect the first time you fire your oven. But just since I've been talking, we've come up, and we're rapidly approaching 2,000 degrees, and I'm going to let it run there for a little while. Make sure we'll check the mechanical limits of the oven, and then we'll keep moving. Okay guys, well that's the update on the Hotshot 360. I hope you enjoyed kind of walking around and seeing how how this thing's developed. And maybe one of these days I'll get a real nice oven. Mine's pretty beat up from all these prototypes. But we've got our first 8. They're gone. All 8 of those over there are spoken for. Ryan Baker was the lucky recipient of serial number 1. He was pretty excited about that. And we've got Brian Carlquist, Matthew Slauson, Brad Barron, Peter Meek, Robert Jordan, Robert Lett, and Josh Freeman have taken the first 8. There's going to be more to come. Looks like we might get these out a little early. I still don't have all my parts in, until all the parts are here. I don't really rest easy until I have the parts in my hand and know they're going to work. And every part that comes in, I have to test, make sure it's going to work. Try it on the prototype, door closures, things like that. So, I have to test everything, temperature test, make sure they're going to take the heat, make sure they're going to live. I don't want to put out a crappy oven, If you are interested in the next batch, send an email to barzeindustrial@msn.com. I'll get you a spec sheet on the Hotshot 360, and we'll make some more. Maybe we'll get some out before the end of the year, okay? Make another batch, all righty? Thanks for watching, and thanks to everyone that supported. Enjoy your ovens.